Use feedback. Good. Okay, so one of my groups back here, Connor, Ashton, and Isaac, someone is remote, right? But they haven't identified themselves. Isaac, do you need to add remote to your username in Zoom? You're Isaac, so you don't need to. So I've got you in the wrong place, wrong spot. So you're here, huh? And then Ashton's here. So it's Connor. Okay. Connor actually here. I don't see him in our Zoom session. We'll count him absent completely. Here's Daniel. Try to get it all fixed. Okay, I think I've got it. More people out. So we want to make sure we're getting everything right, so we know who was sitting beside you and who wasn't. All right. Not fun. Let's do some more if statement stuff. You feeling pretty if statement-y? You guys might have it all down, but we're going to practice some more anyways. Our unit this week is kind of continuing on with our if statement selection structure. In our textbook, little Python textbook, the chapter project does add some while loop aspects to it. So you're going to be adding that kind of on your own, and we won't really be talking about repeating code until next week. So you'll kind of get a little bit of a head start on that before we get all the way going. So last week, we looked a lot at creating selection statements or if statements. And I'm going to bring up our OLab notebook that we created just to kind of remind you guys. Right now, I'm not posting the link to this, but I could. So let's see, I could share this notebook. Let me get it set right. I'm going to change it to sometimes it lets me change it to anyone can view the link. We'll try it. Copy link. And then I'm going to go to our Discord channel and paste it. Oh, look at all those nice reactions. I didn't see those. Yay. All right. If you want to try opening that, it should be just the same as the one you have or close to it because you've done some different things. But if you guys open that link, you should be able to choose to save a copy of it. And then that way you could make your own copy of the notebook. So right here under your file menu, once you have it open, just choose File, Save a Copy in Drive, and then you could just name it whatever you want in your Google Drive. Now, you don't have to save this one if you already have it. You've already got it. I just want to show you that I'll try to share them like that. Do it so it's not giving it to you. That's what I need to know. Let's see if we can get it to be nicer. So it's like at home, it let me change it to where anybody could see it. Let me see if I can. There it is. I just wasn't looking at it properly. Okay, let me copy this one and try it.
Yeah, it's working.
Is it letting you?
Yeah.
Cool. Okay, so OTC won't set you guys up with Google accounts, which makes it kind of a pain, so make sure you can get to it. So I'll try to do that for beginning chapter type things, and we'll do that here in a little while with a chapter 4 one that I'll send out to everybody to kind of share, so we'll have the same starting point. And if you ever have trouble in class, and I know sometimes, you know, you get stuck on something or sidetracked by something else and you don't get all of the information that we have, this should make it pretty easy for us to share that information. You could ask someone else in the class to share their Colab notebook with you so that you could grab a copy of it, or you can ask me to. I would say that I'll try to post our Colab notebook out to Discord every day, but the truth is I'm busy trying to make our YouTube videos and all those other things. So if someone else wants to post it and share theirs, that would be awesome. That seems to work better than me trying to take care of all of them. Sometimes I just miss things, just too many things. All right, so in our chapter 4 studies so far, we have some code now to help us generate a random number. We saw a basic if statement with an else clause for our password. And then we saw the multiple selection if, where we had the elif, you know, if this is true, do this, else if this is true, do this. And we kept going. So we really have seen all 3 different types of syntax that we could use for a selection statement. Did we get all of those into our quick reference for Python? Let's make sure. And again, I know some of you might not need to keep this document. Some might need to more than others. So yeah, we need to add our if statements all together. We don't have anything in here for our if statements. So let's update. I'll go to the end and add a few lines. I'd like something that says like, if A equals B, colon. Now I'm gonna turn off that highlighting. Someone needs to mute, please. So here's our basic if statement. And we could say our keyword is the word if. I've lost my terrible fuchsia color. I'll have to go find it. That's pretty close, pretty awful. Nah, not quite exactly, but close. So my if statement, my if is my actual keyword. So I say if followed by a condition, then a colon. So the only other statement we've seen so far that has the colon, oh, I do have a if statement in here, don't I? I made it, I didn't know why last time. I'm doing A equal B, that's all right. I'll just add a little bit more. The only other statement we've seen that has a colon so far is the def statement. And just like the def statement, the if statement has a body. So everything underneath it that applies to that if statement is going to be indented. All of those things that are indented are the body of the if statement. We saw that if we use an else statement, it has to also be a keyword, the word else, and it also is followed by a colon. The keyword else, then a colon. Because our else clause also can have a body. So whenever we're working with something that has a body, we want to make sure that we have the colon kind of indicating that there's going to be a body there. Then the other variation we saw was elif, E-L-I-F. And with the elif clause, we have to have a condition again. So let me try to get this highlighted right. It's only that part. Yes, sir?
Could you let me into the Zoom session?
Do what?
Can I be let into the Zoom session?
Sure. Get in there when we start.
Oh, okay, sorry.
Because, yeah, I'm kind of busy.
I
try to get everybody in there. You're not the only one.
Sorry.
You are definitely not the only one. There's a bunch. Okay. Thank you for reminding me. Because I just start working and quit checking all these other things.
Okay.
All right. So our elif clause, we have the keyword elif followed by a condition. Then a colon again. So we're seeing our pattern here. I want to get my A equals C to not be highlighted. Word is just the worst thing to use for stuff like this, isn't it? Get some sort of weirdo drawing thing going. I've got like a table tool instead of the actual regular selection tool, so I'm not going to fight with it right now. But in my else clause, I do have to have a condition, and this can be confusing to new programmers. The else clause does not have a condition. Why is that? Why do I have to have a condition with else, but not with else? Think about it. With else, I'm saying, if it's not midnight, if it's any other time, I want to do this other thing. But with else, I'm saying, oh, it's not midnight. Oh, well, let me check. Is it 2 a.m.? Maybe I want to do something different then. Oh, it's not? Is it 4 a.m.? So I am not making that one for all overriding default of everything else goes this direction. I'm furthering my specifications to say I could also have another alternative there. Now, other things that you want to add to your if statement documentation, leave that up to you. There are lots of things that we could put, because remember, we could put all sorts of things about forming our condition. We saw that we can use relational operators like greater than and less than and equal signs. And we saw that we could use logical operators like and not and or. So all of those things for building our condition, we could make those be part of our quick reference notes. But then again, we would be leaving the quick reference realm and starting our own book. So I'm just going to put our basics in there. And I think that's a good spot for us then. I'll minimize that back and come back later. See if there's anything else I need to fix in there. I think we're getting all caught up. So in Canvas, last week we saw that there were two presentations. There they are. And we looked at this extra one. Today I grabbed the Chapter 4 Selection Structures presentation from our textbook, and I've got it open. And I'm going to kind of jump ahead a little bit, because a lot of it is stuff that we already talked about last time. So do take a look at it and review if that would help you. I thought I was in the right place, and then I left that place. So last time we looked at that other presentation and we talked about if statements and just kind of thinking about how they work. In this example, I kind of skipped ahead in that textbook presentation. So if you go forward, you'll find this slide. Let's see if it's numbered. Yep, slide number 48. So it's quite a ways in there. Now, taking a look at slide number 48, what is this code doing? It's some pseudo code. What does it look like it's for? Hey? So labor laws have changed over the years so that it takes people that are our age to understand overtime pay, because a lot of you guys have never had a job that offers that, because they kind of made it where they can get away from it a little bit. But let's talk about how it's supposed to work, okay? Sometimes we get jobs where we just have to work a lot of extra and they give us time off or something like that. But in this example, this company has a certain way of calculating it, which may or may not be the way any other company does it. But they say if they have employees that earn less than $10 an hour, if those employees work more than 40 hours a week, they're going to get overtime pay. So they have to make less than $10 an hour and work more than 40 hours a week. So both of those conditions have to apply. But if that happens, then their pay is going to be upped. So instead of taking their hours worked times their pay rate, which is our normal calculation for calculating someone's pay. We're going to first calculate how many hours over 40 did they work? Well, like 3 hours of overtime. So then for those hours of overtime, we're going to say, how much overtime pay should they get? And their overtime pay should be 1.5 times or time and a half, if you've ever heard anybody say that. That's what they're talking about. They should get time and a half for working overtime. So I should be able to take my pay rate times 1.5 to get that time and a half rate and multiply that by the hours of overtime I had. Then I would do my regular pay calculation, 40 hours times my pay rate, and add in that overtime pay to figure out what my total pay was going to be. So not too bad. This is a standard thing. It's just been kind of in the last couple of semesters, I've noticed that not very many people have jobs that actually do overtime pay anymore. So it's kind of a confusing concept. Let's go to Raptor and put this thing in as a flowchart in Raptor. We had looked at an if statement in Raptor, and I promised you we wouldn't use it very much more, and we're not going to. But I'd like to get this one in Raptor, just as a starting point for us. Excuse me. So before we could do our pay or anything, we need some variables. So I'll use an assignment statement, and let's say we're going to create a variable that's going to be pay rate. And we'll set that to 0 for now. And then we want another variable for their hours. And we'll set that to 0 also. Whenever we're creating an application like this, we can set up the information to prompt our user for this input, or we could actually just set hard-coded values for those variables to be able to run different tests. For us today, let's go ahead and prompt our user for input so that we know exactly what we're working with, and since we haven't done this a lot. So I'm going to ask the user for input. Notice I'm not doing any subprograms or any modules. I'm not organizing this thing at all. I'm just going to have it all straight through code. So the first thing I want to prompt for is pay rate. So within double quotes, I'll put our prompt. What is the pay rate? What variable do I want to use to hold that information? Pay rate. Now let's do the same thing for our hours. We'll say how many hours? Hours worked. And we want that data to go into our hours variable. Now we want an if statement because we're saying that we need to check their pay rate and the hours worked. So I don't know if that if statement is right. I'm going to have to check it. But let's try it with Raptor. So here with Raptor, I have this selection symbol that we haven't used before. Notice it's got the decision diamond in it with a couple of lines coming out of it. So let's grab that selection symbol and drag it onto our flowchart. Oh, it gripes at me. I better save. Okay. I'm going to save this in my CIS120 folder. And I'll call it CH4 overtime pay. And I'll put Raptor in my name, even though my icon is going to show me. So with Raptor, it just puts the diamond in there. And it's like, what's your decision? It already has the yes and the no paths built for us. So we have to kind of make our decision in a way that it will fit into that yes and no path that Raptor has for us. So let's double click on our diamond, our decision diamond, to put in our condition. What we want to know, according to them, is if the pay rate is less than or equal to, or, oh, I'm sorry, greater than equal to 10. So if they make $10 or more, they don't get overtime. And when we're going to put our or clause in here. Or if they've worked less than 40 hours, less than or equal to 40 hours actually. Because remember the basic rule. The basic rule is we only give people overtime if they make less than $10 an hour and work more than 40. So notice how we kind of turned it backwards in this condition. So what we're saying is if the pay rate is greater than or equal to 10, they don't get overtime. If the hours are less than or equal to 40, they don't get overtime. So that's why it's an or condition. So let's click done there. So the yes path means they don't get overtime. So let's do it first. I'm going to add an assignment statement over there on our yes path. Yes?
Sorry to interrupt your flow, but for some reason I'm getting an error whenever I type in everything. So pay rate lesser than 10 or greater than 40 equal. And for some reason when I click on it, it just says that their expected variable or number found less equal pay rate.
You want to share?
Yeah,
let's share.
I'm not a programmer, so
you will be. Show us.
Eventually, this is what my air pops says.
I can't see it. Can anybody see it?
I can what?
Have to enter variable hours. Yeah, after work.
Oh, good one.
What do I put after or? Just hours?
Yeah.
Yeah, so remember when you're making a comparison, you have to have both sides.
Yes,
And
yes.
your H needs to be capitalized.
And my H needs to be capitalized?
Yeah, because that's how you made your variable.
All right. Thank you, sir.
Awesome. Okay. Thank you, guys. So if I look at my pseudocode, we're saying that if our pay rate is greater than 10, they don't get overtime. If their hours are less than 40, we don't get overtime. So we're going to use this formula to calculate total pay. Now, I didn't declare a total pay variable, so I'm going to add one up here at the top, total pay. And of course, it would work without it. I just want to make sure that I'm being consistent in declaring all my variables. Okay, so let's calculate our total pay. On my yes path, I'm going to set total pay equal to the hours they worked times the pay rate. And that's it. Because we know they don't get any overtime. Now we could add a comment to that. Put comment and say regular pay only. So good. Okay, now in our else clause, it says that if we do have to calculate overtime pay, we have to do 3 different calculations. So it's not going to be as simple as it was on our yes path. So let's grab an assignment symbol and put it on our no path. The first calculation is we're going to calculate overtime hours. And that's going to equal hours that they worked minus 40. If I can type. Do you want me to declare that variable? I better. I'm going to use an assignment statement here and say overtime hours is 0. Now I could declare that variable up at the top where I declared all the others, but I'm only going to use it over here in this no path, so I'm kind of putting it over here just for clarity. In the same way, I'm going to use a variable called overtime pay. So I'll set it equal to 0. And then finally, I'll calculate it. Overtime pay is going to equal our overtime hours that we just calculated times 1.5 times their pay rate. Now we could do some PEMDAS here and add some parentheses and make sure our formula ran in the right order, but it's going to come out the same way either way. So we don't really need to worry too much about parentheses there. Finally, we're ready to calculate our pay. So I'm going to use one more assignment statement. And I'm going to say that total pay is equal to our 40-hour normal work week times their regular pay rate plus whatever we calculated as their overtime pay. Now, finally, I have the total pay calculated for each method so I can output the required information. So I'm going to grab the output symbol, but I'm going to make sure to put the output symbol here after the if statement is over. That little tail down there, that's kind of the leftover part of the if statement. I'm going to make sure that goes there so that it runs after the if statement, not as part of it. Now let's output some information here. We're going to say total pay is, and then our total pay variable. Okay, if you're ready to run it, try it and see if it's working. Remember, our speed selector is up here at the top, so your play speed might be set to kind of low or high. I'm gonna wait just a second before I try mine because there are people still looking at it. Let's see if it runs properly. Does it work? I'm going to try and start running, and I should see my variables get declared, my prompt for my pay rate. Let's see, this first time, I'll say that they make $12 an hour, and they worked 40 hours. Now I'm going to watch it execute my if statement. I should see that it follows the yes path, because that person made too much money to get overtime, and I should see their total pay. Now I can run it again, and this time I'll say, oh, let's say they make $8 an hour and they worked 50 hours. They should get some overtime. We should get 10 hours of overtime pay. That looks right. $120 for a total of $440. So that looks good. Now, the thing about Raptor, remember, is you can watch it execute through your if statement so that you can see which code path is followed. And you can tell that based on what you type in to the pay rate and the hours worked, what path it's going to follow. Now, one thing that can be really confusing to beginning programming students, looking at the questions that are at the end of the chapter, is when they give you these questions, they might say, assume the total pay is 12, or the pay rate is $12 an hour. What is the output going to be? And you have to follow this logically, using your head, just following along the pseudocode they give you and come up with the answer. So if I looked at this example here, and we're looking at a question, and the question was, given that the pay rate is 8 and the hours worked is 50, what should the result be? Well, that one's easy for me because I just ran it that way. And I know that if I type in those two pieces of data, I come out with a total pay of $440. But if I didn't know that, I would have to follow through the logic of the flowchart. And that's what they want you to do in those questions. Look at the flowchart. Is my pay rate greater than or equal to 10? No. Is my hours less than or equal to 40? No. So I'm going to follow this path that the thing is true. And it's kind of backwards when we're working with Raptor. So let's put it in Python so it won't be so backwards. Want to? Let's put it in Python. Everybody find your chapter 4 collab document that we were working on before, and let's add this. I have mine somewhere. There it is. This is the one I shared with you. So if you have it open, make sure you save it to your drive as a separate copy so that we're not updating the same one, or you might not be able to find your updates anymore. And I think I want to put this down here after my mood computer, but it doesn't matter because I can rearrange things. So the first thing I'm going to do is click on the table of contents bars and add a section. So this section is going to be overtime pay calculation. And then while I've still got this open, I'm going to click this down arrow to go down, down. Oops, I went up. I want it to keep going down so that it's at the very bottom of my Colab notebook. Now, if it was really cool and the world were right, I would just be able to copy and paste my Raptor notebook into my Colab notebook, right? And then I'd be able to refer to that flow chart when I was creating this code, but the world isn't quite that good yet. So I have to keep them separate, but I could refer to it side by side. So I'm gonna put my Raptor flow chart off to the side, and I'm gonna start creating code for my overtime pay calculation. So I'm gonna click my plus code and start with a comment. And the reason, there's a couple of reasons that we use this one, that I wanted you guys to do the Raptor flowchart and do this algorithm in Python. And that's because our question bank for our tests, for our book, uses this algorithm many, many times for many different test questions. So we want to be pretty familiar with it.
How do I type in a new section without just typing in the title?
Over here, click on the bars to open your table of contents, and then click that plus section thing.
The what?
The plus section. Do you see it? Look up here. See?
Or section. You already added the section, but like when I go to type it, I just types in the title.
When you mouse over, it should come up with a little thing that lets you click plus code, but you can also click plus code up here on top.
All right, got you.
Is it there?
That's there. Thank you.
Sure. You just yell, because some of these things I don't actually say out loud, and that can make it hard. If you're thinking it, you're probably not the only one. Okay, so our purpose here, we'll just say calculate total pay. You'll see a lot of times as we develop that I'll ask you to convert things from a Raptor flowchart to Python, or from Raptor to Pseudo Code, or Pseudo Code to Python. And that's because I want your brain to just look at all these things as though they're the same. I'm looking at an algorithm, I see what it does. How could I make it be in another language? I would just need to figure out how to implement these things in that language. All right, so we've got our comments. Let's declare our variables. We're going to use our global keyword. So we have pay rate, and hours, and total pay. Now in our flowchart, we use the input function to get our pay rate first. So let's try that one. For our pay rate, we want to use the input function in Python. And I want my prompt to say something like, what is the pay rate? And remember, we need to put a space after that question mark, or it'll be squished right up to it when we run it in Python. Now we need our pay rate to be a number. And of course we know in reality that should be a float, but for our needs here for our program, we could make it an integer, right? Because we're not really doing anything fancy with it. We could go either way. So we can say pay rate equals float pay rate. Or remember, we could wrap our whole input function in that float function to make it convert that to a float. Now, the other thing we need is our hours. So again, we'll say our hours is going to be an integer, and we're going to use the input statement to prompt them. And we want our prompt to say how many hours worked. So a few things, we can put comments on those same lines. Remember, we're casting as a float. And in the input statement down here, we're casting as an integer. So we're ready to do our if statement. So let's put a comment. Decide if they get overtime pay. So for our flowchart, we said if the pay rate was greater than or equal to 10, or the hours was less than or equal to 40. And in that case, they're just going to get regular pay.
Should your hours have an S at the end of it?
Yeah.
Oh, thank you. Yeah. Make it mad, huh? And if you notice, because I put that line comment here, the IDE didn't automatically indent for me when I went down. So if the last character you typed isn't the colon, you can kind of mess up that auto indenting. So I need to press tab since it didn't indent for me automatically. If yours indented for you automatically, you're fine. Now, under our if statement here, we're saying that we're going to calculate regular pay if this if statement comes out true. So our total pay would be equal to our hours times our pay rate. Now, if it's not true, we're going to use our else clause logic. And in our else clause, we're going to declare a variable overtime hours equals 0. And overtime pay equals 0. Then we're going to use those variables. Overtime hours equals the number of hours they worked minus 40. Overtime pay then is going to be those overtime hours that they worked times 1.5 times their pay rate. And finally, we can calculate their total pay equals 40 times their pay rate plus that overtime pay. So now you can see why employers like to not pay overtime, right? Because it's a real complicated formula. Not just because it costs them money. It's not that complicated. But it can be a little messy. Now, we are done. The if statement is over, is done. We're done with it. So let's do our print statement for our output. And we said total pay is, and then I've been being super mean to you, and I've just been saying, put a comma in your print statement because print statements don't like to output these numbers and these strings. Well, let's get past that. Whenever we want to output a number as part of a concatenated string in Python, it's going to give us an error. So I'm going to expect an error on that line of code. I'm going to leave it there so you can see what it does. Because that's our last line. We should be able to fix it very easily. So let's see if our program is working. We've got everything in place here. Oh, I can't assign values on those globals. I do that every time. Let me get rid of the equals. Whenever I'm copying off those Python or those Raptor flowcharts, I do that. Now, these other ones are fine because they're not global, so they should be okay. Let's see. All right, so it's asking me, what is the pay rate? And I liked that 8. And now I should get prompted for how many hours were worked. So I'll do 50. And then I finally get that error I was telling you about. Notice it tells me it's on the print statement. And it says that there's a type error. The type of data you're trying to print is wrong. It must be a string, not a float. Well, it's right. We said total pay was a float. And here I am trying to print as a string. So what can I do? I got to cast it as a string. So just like I can cast something as an integer or a float, I can cast it as a string just by putting the str function in front of it. So now I've said print total pay is plus pass total pay as a string and print that string. So now we shouldn't get an error when we try to do that print.
Well, now I definitely get an error after adding that double button.
Yeah, you get it? Is it mad then?
Yep.
So 8 and 50. So you should get your total pay, it's 440. Good?
I get a syntax error right after I enter the pay rate in my hours, and it goes down to lines 10, 11, and 12. Ooh. It says the hour isn't defined.
So is it one up here? Does it need the S?
I'm not sure. I'm looking right now. The pay rate equals 10 or an hour. Is it hours right there? Or
Whatever you prompted for, Good job.
All right, works out like it.
Is it working?
Yep.
Yeah.
Smaller issues.
Now, if you guys wanted to get your Raptor flowchart in here, which I sort of do, you know, you could use the snipping tool to create a snip of it, and then you could add text and paste it or something, but it's probably not worth all the trouble. I'm like so sad that we can't get it in there together because I think it would be helpful. Okay. Anybody need any help with that one?
Yeah. When we use 10, like put the pay as 10 or more, Like it stops like right then and there.
Oh, okay.
Yeah. Like,
Well, shouldn't there be something that tells us that you don't get overtime pay at least? You know? You don't meet the conditions for this.
What do you want? Here, I'll
Like, put in 56 for pay rate.
do what?
Put in 56 for pay rate,
Okay.
and then put in like 78. Okay, that's weird.
all right, so what did we get?
Yeah.
Should we share your screen?
Yeah, it's got a screen.
Let's see what's going on. Sounds like we have a difference. Going? There.
Yeah, so it's,
So let me ask you a question. Where's that print statement? Everybody look at their screen. Where's their print statement? Is it part of the else clause or is it on its own? It's part of the else clause. And I'm using them as an example because it's really important with Python. I can say it a million times, but not until we accidentally do it. Does it matter? That makes sense? You weren't getting anything then, huh? Woohoo! Sure. Okay, that looks great. Okay, so now we know all about calculating overtime pay. And this is one of those times where we get to get that little life lesson along with learning some programming, because if we hadn't ever calculated overtime pay before, hopefully you get it even if you make more than $10 an hour, right? But most companies don't let you work 40 hours a week anymore, so you keep it to overtime. So this calculation is going to come up and haunt you on our unit exam that's coming up, just so you know, and they'll flip it around a bunch. So we should try that. We have this great program that we've created. How could we flip it, our if statement? What if I changed this if statement to say if pay rates less than 10 or hours greater than 40? Would that work for the same situation? How could we flip it around? Let's think about it. Let's say I want to comment this out sort of and redo it. So I'm going to duplicate all of this code, copy, paste, and then I'm going to put 3 quotes or 3 double quotes up here and 3 double quotes. So now I have our original code set up as a comment block. It's commented out per se, so it's not doing anything, but yet it's still there. So if we wanted to refer back to it, we could. So I want to change this if statement and I want to switch it. So I want to make it to where by default, it's going to do the overtime pay calculation. So I want this if statement to be reformulated so that it comes out as true for somebody who deserves overtime pay. So first of all, if they're going to get overtime pay, they have to make less than $10 an hour, right? So I need that to be a less than. Not less than or equal to, just less than, right? Because if we said it's greater than or equal, the less than would not be inclusive if the greater than or equal was. Makes sense about whether we're including that actual 10 or not. So if they get less than $10 an hour, what's the other half of our if statement to decide they get overtime? Their hours has to be greater than 40. So now, what about this logical operator? Is or still the correct? What should I change that to? And, exactly. Because I'm rearranging the logic there. So if I rearrange that logic, I have to make this into an and. So now we have our true condition to be true if they get overtime, but false if they don't. So we just switched it around. So I'll add my else clause back in. And with the else, I just want a simple calculation. Okay. So look at those two. And notice our difference is the if statement. So we have to really think about what that condition is. In this condition, we're checking to see if they should, if regular pay should be our true calculation. Down here, we're checking to see if overtime pay should be our calculation, our true calculation. Now, we should get the same results out of this application if we run with the same test data. So think about that condition there, because that's all we are really changing is the condition in our if statement. So on the quiz and the unit exam, they'll use this overtime pay calculation algorithm quite a bit, and they'll change up this if statement because they found that they can confuse students a whole bunch just by changing the wording of that one line. They can make people come up to me and say, this is the exact same question, only it's a different answer. And I can say, no, it's not the exact same question. See how the condition is different? So I'm just kind of telling you, be real careful with those questions, because that's how they try to make it to where you have to pay attention really, really carefully. So it's not a way of trying to trick you. It's to try to make you pay attention. Okay, so they have that same thing here. If we have our differences in our condition, would change the way our flowchart looks. So you guys all understand that, but it can be something that you really have to think about when you're looking at it. So give yourself time, you know, don't try to do it when you have a lot of distractions. Okay, and we've seen a bit about our logical and relative operators. I just wanted to skip ahead a little bit in some of this. Now, the ASCII code question might get a few people. I think I've mentioned it enough to try to bring it out to everybody. Remember, we have that code table that says every letter and special character was assigned a unique numeric code. And that is how string characters get sorted. And this is how they get compared. So if I were comparing the letter A to the letter Z, the system would go find the ASCII code for each of those letters and use that code value to make the comparison. So the uppercase letter A would be less than the uppercase letter Z. So we can always look back to that code table to see where those values come from if we can't remember why one letter would be less than another. And I think in your example questions at the end of the chapter, they ask you about a special character like a parenthesis or something to make you really look at that ASCII code table. So all of those strings are assigned that ASCII code value, and that can make them have a nice greater than or less than order. Now, whenever we're working with strings, we do need to be careful, and sometimes we can come up with illogical or unexpected results when we're comparing strings. So we do need to be aware of that. It's a little bit different than comparing numbers. Let me get to a spot here. I'm just sneaking ahead. Because I want to show you these important things. So when we're using if statements, we're going to use them all the time for things like we just did, deciding how much to pay somebody. Did they have overtime hours? Was their bank statement, was their bank balance above zero? Did it go below zero? All of those kind of conditions we need to check for all of the time. But we can also use if statements for other important things. And one of them is defensive programming. Now, you guys have done great so far this semester. I said, be sure to type a number in or your program will break, right? It won't be able to handle it. That's because we're not doing any defensive programming yet. We haven't started doing that. So if we type in the letter A, where our program was expecting a number, it'll crash because it can't do a calculation with the letter A. But we could actually write some if logic, some if statements to check for valid numeric input. Or in this case, they're saying that they want the cost to be greater than zero. So not only do they want it to be numeric, they want it to be something. So I can write defensive programming logic, defensive code that makes sure the valid data is entered. So just like driving, I always think about driving in Springfield and they say you must drive defensively. That means that you should wait when the light turns green, you know, to make sure nobody else is running a red light from other direction. Because if you're not defensive, you could end up getting hit. And that's exactly what we're doing with our code, is we're gonna take that extra bit of precaution, even though we shouldn't have to. The user should know to type a number in if that's what we say we want, but we're gonna go ahead and double check just to be sure. So in this example, they have a cost value, and if the cost is less than zero, they're gonna write out an error message. Preventing bad data. Now we can also do some error trapping where we say, we're not gonna let you continue on in this program until this error is fixed. Here's one. We say that we can't divide by zero. Dividing by zero is an illogical math condition. So if we try to divide by zero, we're going to get a runtime error from Python. It's going to crash. So we have to do whatever we can do to prevent that from happening. So right here in this code, they're going to do a division process. Before they actually do the division, they check and make sure that their divisor is not a zero. If the divisor is a zero, they're going to write out some sort of error message instead of letting Python just crash the program, because you know how annoying it is when stuff just crashes. So this way we can catch it, trap it, and ask for different input. Now another error that we could encounter that we can prevent with defensive programming is if we're trying to take a square root. So we know that in our process somewhere, we're going to have to get a square root of a number. We can make sure that that number is positive. We can't call the square root function on a number that's negative. It would cause, again, a runtime error. So in this code, they just put an if statement in, make sure the number that they're going to take a square root of is greater than zero. Now, whenever we're doing defensive programming, we are always thinking about ways that people could break our application or trying to, because you guys know how frustrating it is when something crashes on you and you have to get all the way back to where you were to try to continue on. Is it going to do the same thing again? You always have to try it just that once to see if it's going to crash again. Well, when you're the developer, you need to try to walk through your code and do that desk checking. Make sure to look for places where these kind of errors could happen. As you're desk checking, looking at your code, you might say, oh my goodness, I didn't even realize right there I'm doing a divide. it never even dawned on me that I need to check and make sure that that number is not a 0 that is at the bottom of that division. We can do that desk checking and find things like that that we might not run into if we're just running our program over and over and over. When we're desk checking, we want to make sure we do all of our calculations manually with the calculator, any different way we can. Make sure that we try test data that's going to test every branch of our program. Check for divisions by 0, negative square roots, all those kind of special functions. Now, another place we might use an if statement, and we're going to try these today or next time, would be a menu-driven program. What's a menu-driven program? You think of one?
Kind of like an interactive menu that like you can like physically like click and go to different menus.
That would be
cool.
That would be one. And what's like a really old one that you would think of where you had to put like a number 1? I know because people always tell me that Xbox used to have a real old menu kind of system that you had to use. And when we can create a menu system like that, and we're going to use an if statement to see what the user picked, right? Which item did they click on or which item did they type in? So whenever we're doing a menu-driven program like that, we'll have to have some if statement logic to decide what to do based on their choice. So whenever we're using a menu-driven system like this, the user usually has a main menu. We see graphical menu systems like on Netflix where we're given all of our choices. It's still a menu-driven system where when they finally click on that item, we have to have some sort of logic in our code that checks to see what they clicked on and does some sort of action depending on what they clicked on. So a menu is kind of our older one. Here's a really old menu, and that's kind of what we'll be trying for our early Python code, where if they typed a 0, we would exit, etc. So let's try some. In our chapter 4 collab document, let me see if I can get to my other one. Hang on for me. I think I can open 2 at once. That's what I was liking. I've done something to the one that I wanted us to work on together. So that'll work out. You know, I'm looking at the time here, and it's like we really probably ought to break for lab. I keep running you guys through and then making it to where Wednesday is almost all lab day. I want to do that this week. We're going to stop now and take our lab time because I know some things are getting behind. And let's take a look at what is coming up this week. And next time, we'll do some more examples and we'll look at the error checking stuff. But I don't want to run us all the way through every single time. So this week you have 2 new assignments. You should have plenty of time to work on these next time, and then they will carry over. The Magic 8-Ball is the assignment that you'll work on your own. The Guess My Number and Update is the assignment you'll work on with your study group. So this Guess My Number one, we'll start on next time after we've done our sample code that we'll do. We have a few more samples to do together. So in this lab, Guess My Number, you'll actually go to the Python programming book because the Guess My Number is the chapter 3 project. So it does include a while loop, and it gives the user the opportunity to continue guessing a magic number. You'll work on that with your group, getting it pulled out of the textbook, but we'll also update it to count how many tries the user has gotten and give them only a limited number of tries. So I'll ask you to make that update. The Magic 8-Ball is one I want you to come up with on your own. So you can start looking at that if you want. And in our Magic 8-Ball, we want to generate a random number. And then the random number is going to determine what kind of action you should suggest to the user. So you'll ask the seeker for their name, tell the seeker to think of their question, and then generate a random number as their lucky number. And then these are possible lucky 8-ball things that could be generated. I'd like you to have a minimum of 9 possible answers, 3 from each category, but you could redo some of these answers if you want to, so they don't have to follow those exact words. So make your magic 8-ball work however you want it to. Questions about that? Okay, so next time we'll do a couple of samples in our collab document, and the rest of our time will be lab time. So today, I would recommend you get with your study group and make sure that you guys have Unit 2 collab notes created, that everybody can access them. Start getting your Unit 2 collaborative notes ready, because next week we'll have our Unit 2 exam. It's only going to be over Chapter 4, but that is quite a bit of content actually. So making sure you've got your notes all working, making sure you can get to each other's collab documents to share things and all that kind of good stuff. Any questions before we break for lab time? All right, we're lab time in it.
I got a lot of answers, but like someone who's programming questions threw me off. They were Pseudo Code.